Hello everyone, in this video we are just going to control the onboard LED of Nodemcu with the help of another app available in the ThingSpeak IoT platform, that is nothing but this ThingHTTP. Let's get started. So this ThingHTTP is nothing but an application available in this ThingSpeak IoT platform, which is useful for sending HTTP requests to other web services in the world. So you can use this ThingHTTP for sending HTTP requests to other web services, or you can send a web request to our own ThingSpeak IoT platform. So this is similar to the Postman application that we have been using in the previous lectures for sending a web request in the format of HTTP. So similar to the Postman, this HTTP is available in this ThingSpeak IoT platform, which is useful for sending web requests to other web services or to our own web service. So now let's try to understand the concept of the project that we are going to build with the help of this ThingHTTP. So this is also a full-fledged IoT application project, but this time we are just going to use a new feature called ThingHTTP available in the ThingSpeak IoT platform. So here you can see on the left we are having a IoT transmitter Nodemcu. On the right we are having IoT receiver Nodemcu. So we are just going to use two Nodemcus in this project, and here in the transmitter section we are just going to interface a variable resistor, that is the simplest analog sensor, to the A0 channel of the Nodemcu, and we are just going to continuously upload the step value, that is starting from 0 to 1024, which will be fetched from the A0 channel with the help of this variable resistor to the channel field available in this ThingSpeak IoT platform. And if this value that we are passing from the transmitter is exceeding the 50% value, let's take it to be 500. If it exceeds the number 500, I will be triggering a web request with the help of React and ThingHTTP. So as I said, this ThingHTTP is useful for sending web request to any web service. So we will be triggering a web request for updating the command available over here in the talkback queue of the same ThingSpeak IoT platform. So if the value is greater than 500, I will be configuring a React application, and in that React I will be sending and configuring a ThingHTTP for sending a put request, and in that React I will be configuring a ThingHTTP for sending a put request for updating the command available over here in the talkback queue of the ThingSpeak IoT platform. And if it exceeds the value 500, I will be updating the command here to be L1, and if it is less than 500, I will be transmitting the command or updating the command to the talkback queue to be L2. So this is the transmitter section. So we can manually increase and decrease the value by rotating the knob of this potentiometer, which is connected to A0 of the Nodemcu. So by manually rotating, we can increase and decrease the step value that we are passing to the channel field available over here. And if it is greater than 500, I will be transmitting L1 using the ThingHTTP put request, and if it is less than 500, I will be transmitting L2 to the same talkback queue available over here in the ThingSpeak IoT platform. And regarding the receiver section, and we are just going to write a program for reading the talkback queue available over here in the ThingSpeak IoT platform. So the same program that we have been using in the receiver sections for the past few projects. So we will be continuously reading the talkback queue available over here in the particular command ID. If I receive the command L1 over here in the IoT receiver Nodemcu, I will turn on the LED which is available in the Nodemcu. So there is a LED which is connected to D0 of the Nodemcu, which is available on board in the Nodemcu. I will be turning on the LED when I read the command L1 in the particular command ID. And if I read the command L2, I will be turning off the LED. So this is the program that will be running in this receiver Nodemcu. So based on the step value, if it is greater than 500, I will be loading the command L1 in the talkback queue, and if it is less than 500, I will be loading the command L2. And in the receiver section, based on the command present in the same talkback queue that has been updated by the transmitter, if the command is L1, I will be turning on the LED, and if the command is L2, I will be turning off the LED. And this time we are just using a new feature in this ThingSpeak IoT platform, that is nothing but ThingHTTP, which is useful for sending web requests to any web services in the world or to its own web service. So let's build this project step by step. And now, starting with our project, let's take the receiver section first. So we are just going to write a program in this receiver Nodemcu for continuously reading the command available in the talkback queue of the ThingSpeak IoT platform, right? So this is the same program that we wrote for reading a talkback command available in the ThingSpeak IoT platform. So we are just going to use the same program. I have provided this program in the download button below this video. And if you are watching this video on the YouTube, you just want to enter my smtrainingacademy.com, and then you just want to enroll for the required course, and each lecture video is provided with the download button, and you can find the resources for that particular lecture in that download button. And now you can see these are the common headers that we have been using till now. And here in the initialization part, we are just initializing the serial monitor with certain baud rate, and then we are just initializing and configuring the D0 pin, which is the LED pin, as output for turning on and turning off the LED. And after that, we are just connecting the Nodemcu to the Wi-Fi router. Now coming to this function. So this is the same function that we have been using in almost all the lectures from the beginning of this course. And here you just want to change the SSID of the router and password of your router for connecting the Nodemcu to the Wi-Fi router available in your home. So here you just want to provide the username, and here you want to provide the password. And if you are not having a Wi-Fi router, you just want to turn on the hotspot in your mobile phone, and then give the username of the hotspot and password of the hotspot over here for connecting the Nodemcu to the hotspot for having the internet access. And that's all about this function. Now coming over to the logic, you can see in this line we are just fetching the command available over here in the talkback queue. That is over here. You can see I'm having a talkback here which I have created, and here you can see I'm having a talkback, and it is having the command L1 and with the command ID 233333827. So it is having one command in the position 1 which is having L1. So for reading this command, I just want to write a program in the Nodemcu. So our Nodemcu must be continuously reading this talkback queue with the command ID 2333827. So for that, I'm just using this get command function. You can see this get command function is useful for fetching the command from the talkback queue. So this is the host name, and this is the talkback ID 42886. You can see talkback ID is 42886. So I need not change this. And command ID is 233333827. So you can see this is the same command ID. So this is the same program that I used in the previous lecture. So I need not change these things. And this is the API key of the talkback. You can see A7DW. So this is the API key of the talkback. So in your case, you will be having the different API key, talkback ID and the command ID. You just want to change that also. And following that, I'm just getting the HTTP status. If it is okay, I will be getting the response from the talkback of the ThingSpeak IoT platform, and from that response I'm just extracting out the command, that is either L1, L2, L3, L4, whatever the command it may be. I'm just extracting out the command from that entire string that I receive as a response from the ThingSpeak IoT talkback feature. And after that, I'm just storing the result in the variable called result. This is a string variable. I'm just storing that. And finally, I'm just returning that as the return type to this function. So here in the command string variable, I will be receiving the command whether it is a L1, L2, L3, whatever is available over here, that will be received here in my command string variable. And if it is L1, I will be turning on the LED. by making the D0 pin low, and if it is L2, I will be turning off the LED by making the D0 pin high. So that is these two if conditions. We know that the onboard LED, that is the blue LED available in my Nodemcu, is connected with the cathode to the D0. So for turning on the LED, I just want to make the D0 pin low, and for turning off the LED, I just want to make the D0 pin high. And finally, I'm just printing the command that I receive in the serial monitor, and then I'm here waiting for 1 second, that is 1000 millisecond. So for every 1000 millisecond, the get request is sent from the Nodemcu, that is the receiver Nodemcu, and the command available over here is continuously read for every 1 second from our receiver Nodemcu. So that is the logic of this program. And if the command is L1, the LED will be turned on, and if the command is L2, the LED will be turned off. So the command that we read from the IoT device decides whether to turn on or turn off the LED available in the Nodemcu, which is connected to D0. So this is the receiver IoT program, Nodemcu program. I am just going to upload this program to the Nodemcu that I have connected to the PC USB port. Now the program has been successfully uploaded to my Nodemcu. I am opening the serial monitor. You can see the command L1 is continuously being received for every 1 second, because the L1 is available over here in the talkback command queue, and that is why we are just receiving the L1 over here in the serial monitor. And now let's try to test this receiver section only, and then we will try to program the transmitter, and then we will test that separately, and after that we will integrate both for building our project. Now let's test the receiver section only. So as usual, I am just going to use the Postman app over here for sending the put request for changing the command over here. So this is the put request, right? So I am just copying this for updating the command over here to be L2. I'm just deleting all these things and I'm pasting it. Now in between these, I'm just going to paste the question mark. And finally, we just want to concatenate command underscore string is equal to L2 for updating the command here to be L2. I just want to copy the command ID also, and I want to paste it over here in the place of command ID. So when I send this put request, change this to be put. So when I send this put request from the Postman, the onboard LED will be turned off because the L2 will be updated here in the talkback with the command ID 233333827. So let's test this. So this is the hardware. You can see the onboard LED is turned on because the L1 is available over here in the ThingSpeak server. Now when I send this put request, this will change the command there to be L2. You can see the L2 has been updated in the Postman. The updation has been successful and my Nodemcu LED is turned off. And when I change the command here to be L1 and when I update this put request, you can see the onboard LED is turned on. So now our receiver section program is working fine. You can see the LED is turned off. When I send L1, the LED is turned on. So now we have clarified and confirmed that our receiver section program is working fine, and now let's move on to the transmitter section. And now that we have programmed the IoT receiver Nodemcu and we have completely tested the working principle with the help of Postman, and it is working fine. And now let's move on to the IoT transmitter. So as we did in the initial lecture of updating the analog values to the channel field available in the ThingSpeak IoT platform, we are just going to use the same program. So this is the program that we wrote for uploading the analog data that we fetch from the variable resistor using Nodemcu to the channel field available over here. So this is the channel field, right? So this is the channel field, and we just wrote this program for uploading that data to the channel field available in the ThingSpeak IoT platform. So we are just going to use the same program. You can see the channel API key is available over here, 8H9. So that is right over here. You can see this is the right key. So we need not change that. And again, I'm just going to write to the same field available, that is field number 1. So field number 1. So I need not want to change that also. And after that, you can see the data that I want to write is the parameter of this function, send get request. So we need not change anything. So in your case, you just want to change this API key and the field number if required. So this API key will be different, and if you are writing to the same field number 1, you need not change this field number, let it be 1. And if you are writing to different fields, you can change the field number right over here. And regarding the data, you just want to pass as a parameter to this function. So this function send get request is useful for sending a get request for writing data to the channel field available over here from our Nodemcu. And regarding this function, this is the same function which is useful for connecting the Nodemcu to the Wi-Fi router for having the internet access. Here you just want to give your SSID of the router, that is username of the router, and then the password of the router. If you are not having a Wi-Fi router, you just want to turn on the hotspot in your mobile phone and then give your username of the mobile phone and the password of the mobile phone hotspot right over here for connecting the Nodemcu to the internet access. And these are all the two functions that is used in this program. And regarding the logic, you can see the step value variable is continuously reading the A0 channel of the Nodemcu to which the variable resistor is connected, and once read, this step value will be having the values between 0 to 1024 based on the knob rotation of the potentiometer. And once done, we are just passing this step value directly as a parameter to this send get request function. So the get request will be sent from the Nodemcu to this channel field available over here, and it will be updated over here in this channel field that is available in the ThingSpeak IoT platform. And here we are just giving a 16 seconds delay, that is 16,000 millisecond delay, because as we know, the free account in the ThingSpeak server can upload only data once for 16 seconds. So that is why we are giving 16 seconds delay right over here. So for every 16 seconds, the analog step value is read from the analog channel of the Nodemcu from the variable resistor pin, and that will be fed to the channel field available over here as a get request. So this is done, and you just want to change, as I said, you just want to change the API key and the field number requiredly, and after that you just want to change the SSID and password of the Wi-Fi router in this program. And that's it. I have also provided this program in the download button below this video. You will be finding two programs, one for IoT transmitter and one for IoT receiver, and you just want to change the required fields like API key, field number, talkback ID, and all the other things, SSID, password, as per your requirement for keep your IoT devices working. And if you are watching this video on YouTube, you just want to enter my smtrainingacademy.com and then you want to enroll for the required course, and each lecture is provided with the download button below the lecture, and you can find the resources for that lecture in the download button below the lecture. So now let's continue, and you can see I will be sending a get request for uploading the data, that is writing the data to the field available over here. I am just uploading this program to the IoT Transmitter Nodemcu. I am just connecting my Nodemcu to the PC, the USB cable, and I am uploading this program to the Nodemcu. And here you can see these are the general headers that we have been using till now from the beginning part of the course. And once done, you can see we have completed the IoT receiver section, which will be reading continuously talkback queue available in the ThingSpeak IoT platform. And now we have completed this section also. You can see we have successfully programmed the Nodemcu for transmitting the analog data to the field of the channel available in the ThingSpeak IoT platform. Now the only thing left is we just want to configure the React for ThingHTTP for changing the talkback command available in the talkback queue based on the step value of the channel field available over here. So that can be done in the IoT platform itself. So now for creating that, just click on this apps and click on ThingHTTP. Now click on this new ThingHTTP. Here give your name request 1. I'm just giving it as request 1. Here what I just want to give is, I just want to send a put request for updating the talkback command, right? So for that I just want to go to the talkback menu. I just want to change the talkback available over here, right? So I'm just copying this put request and I'm pasting it over here. I just want to give a question mark here, and in this place of command ID I just want to paste this command ID. I'm just pasting this command ID, and at the end I'm just going to concatenate the string. Command string is equal to L1. So this is the ThingHTTP, that is the request 1 which we are creating is useful for turning on the LED. Okay, we are just going to create two ThingHTTPs, one for turning on and another one for turning off. So that's it. Now change the method here to be put, and after that click on save ThingHTTP. Now you can see, if this ThingHTTP is triggered, this put request will be sent, which will be updating the talkback available over here with the command L1. Now coming to the previous apps, I'm just going to create another ThingHTTP for turning off the LED. Now create another one, new ThingHTTP. I'm just giving the name here to be request 2. Here also I'm just going to now here we know that this is the put request for updating the command L2 to the talkback queue which we used in the Postman app. I'm just copying this and I'm pasting it over here and changing the method to be put, and that's it. Now I'm just clicking on save. Now we know that in this apps, this request 1 is useful for updating the command L1 over here, and this request 2 ThingHTTP is useful for updating L2. Now we just want to create React applications for this ThingHTTP for turning on and turning off based on the IoT transmitter data. So for that I just want to create apps React. Click on new React. ThingHTTP on numeric, and I am just going to check from the channel 1 of the field available in ThingSpeak IoT platform. Field 1 is as usual. I am not going to change the field also. If the value is greater than 500, I will be triggering a ThingHTTP which is nothing but request 1. So if the value is greater than 500 in this React, it will be triggering the ThingHTTP request 1. That means a put request will be sent from the ThingHTTP to this talkback available over here for updating the data L1 using this React. And now that's it. You can see numeric data insertion channel 1 field 1. If the field 1 is having the greater than value of 500, I will be triggering an action of ThingHTTP with the request 1. We configure the request 1 for sending and updating the command here to be L1. Click on run action each time condition is met and save React. And nextly I'm just going to create another React ThingHTTP off. Now I'm just going to select numeric data insertion channel 1 as usual field 1. If it is less than or equal to 500, I'm just going to trigger an action of ThingHTTP with the request to run on each time the condition is met and save React. Now we have successfully created Reacts for each of the ThingHTTP that we have created. So this request 1 will be updating L1 over here, and this request 1 will be updating L2 over here. So this ThingHTTP is nothing but a modified version of this Postman app that is available in the ThingSpeak IoT platform, and we have created React for both the ThingHTTPs. So this React app over here in the ThingHTTP on is useful for writing the command L1 when the channel data is greater than 500, and this ThingHTTP off will be writing the data L2 in this talkback when the channel data is less than 500. So for each ThingHTTP you just want to create a React app. So coming to our transmission program, the transmitter IoT device is also programmed. Now we have successfully wrote the program for transmitter for transmitting the analog values to the field available over here, and then we wrote the receiver IoT device for continuously reading the talkback available over here, and then we created the React and ThingHTTP for sending put request for updating the talkback available over here in the talkback queue of the ThingSpeak IoT platform. Now I hope you understood the concept of the project that we built with the help of ThingHTTP and React app with the help of IoT transmitter and IoT receiver. Now let's see the output in the hardware. Now our output will be simple. Based on the knob rotation of the variable resistor which is connected to A0 of the IoT transmitter, the value will be changed in the field over here, and if the analog value that I provide in the analog channel with the help of knob rotation of the potentiometer is greater than 500 in this field, the L1 will be updated, and in my receiver Nodemcu I will get the LED turned on. That is, the blue LED available on board in the Nodemcu will be turned on, and if the value provided is less than 500, the LED will be turned off. So these two Nodemcus that I am going to use in this project is connected wirelessly via internet. So this is controlled with the help of new application available in the ThingSpeak IoT platform, that is ThingHTTP. That is useful for sending web requests to various web services in the world. Now you can see in my channel field the latest updated data is 12, which is from the transmitter Nodemcu, that is this Nodemcu right over here, and so now I have just received 19. So in my hardware you can see this is the transmitter Nodemcu device and this one is the receiver Nodemcu device. So I have connected the variable resistor to the A0 pin of this transmitter Nodemcu, and 5 volt is connected to 5 volt, and one end of the variable resistor is connected to 3.3 volt, and other end of the variable resistor is connected to ground. Now when I try to increase the step value by rotating this potentiometer, I have reached the other extreme end, so that I will receive the maximum step value 1024 in my transmitter Nodemcu analog channel, and let's just wait for next updation in the field. Now when I refresh this page, you can see the latest updated data is 1024, which has been transmitted from the transmitter, so that my onboard LED in the receiver Nodemcu device is glowing. And when I try to reduce the step value by rotating the knob, again I received 1024 in the next 16 second cycle, and now you can see the LED is turned off because I reached the minimum value 19. Now the field minimum value here is 19, and now when I slightly increase the step value, you can see the LED is glowing because the value that I got in the field is 670, which is greater than 500. And when I slightly reduce it below 500, you can see I got 160 as the step value, so the LED is turned off. Again, when I slightly increase it, now you can see I got the value 668. So the onboard LED is turned on because the value is greater than 500. Similar manner, when I reduce it, the LED will be turned off. You can see the LED is turned off because the value that I received is so now you can see our project is working fine, and we have successfully built the first project using ThingHTTP of our ThingSpeak IoT platform. So we used several features of the ThingSpeak IoT platform, right? We used the talkback of the ThingHTTP, and then we used the channel of ThingHTTP, and along with that we used the ThingHTTP web services request, and along with that we used the ThingHTTP along with React for building this project. So this is the output that I got in my hardware. See you in the next lecture. Thanks for watching.